A perfect square trinomial is a trinomial, meaning it has three terms, that if you were to create an area model or use algebra tiles, it would create a perfect square, not a rectangle. Which means if you consider a perfect square, now that's kind of iffy. A perfect square means that the one side, the length, is going to be the exact same as the width, right? That's what a square means. All sides are the same length. So if you were to create this thing out of algae tiles, it would create a perfect square. So it has to work out just perfectly in order to be able to have an area where the same sides are the same length. When you look at the trinomial, for example, this one, 25x squared minus 20x plus 4, maybe in the past you've done some investigating, and what you notice here is when we look at a trinomial where this first term is a perfect square and the last term is a perfect square, we call this a perfect square trinomial. And if we factor it, we're going to get the exact same factors, two of the exact same, just like the length and a width of a perfect square. So let's go ahead and factor this. There's a shortcut we can use. It simply says we know we're going to get two factors, and in fact they're going to be the exact same, so really I would only have to write this once with a square symbol, but let's write it twice. To find the first term, we take the square root of this. The square root, or what times itself, gives you 25x squared. Well, 5x is the square root. 5x times 5x gives you 25x squared. Okay, then the second term, excuse me, is going to be the square root of the last term. The square root of 4, or what times itself gives you 4, is 2. That goes there. Now, the signs, this will be the same sign as here. We're going to have a subtract. Okay, had that been a positive there, we would do a plus. I'll do one example like that yet. And so you can see it's the exact same length and width are exactly the same. So we can write this now as 5x minus 2 squared, meaning multiplied by itself. And again, you can easily check that answer by foiling it or multiplying those two together. Firsts multiplied by outsides, 5x times negative 2, multiplied by insides, negative 2 times 5x, multiplied by lasts, or negative 2 times negative 2 is plus 4. Is that what we started with? Yeah, negative 10x minus 10x, that's the negative 20. Yes, it is correct. Okay, with this strategy, let's do one more. This is number 2 from your assignment. Now, of course, when you're working today on your assignment, we are dealing with all perfect square trinomials. But if you were just factoring and going through it as normal, you would know there's no number in front of the x squared, or it's a 1, I should say. And so you could factor it using reasoning, using tiles, or using an area model, even if you don't notice that it's a perfect square trinomial. But if you do notice that this is a perfect square, and this last term is a perfect square, if that catches your eye and you do notice, then you can factor it right away using your memorized steps that it's a perfect square trinomial. The first term will be the square root of x squared, which is x. The second term will be the square root of the last term, which is 7. And then you match that first sign. So x plus 7 squared, or x plus 7 times x plus 7, are the factors of the original trinomial. Just to take it one step further, this means that the length and the width in the area model will be exactly the same. So if I was to draw this square I could say that this is x plus 7 on that side, and we know that this is x plus 7. And I could actually draw that out. This is x width. I should have written x plus 7. Write it that way. This is the x length. And then there'll be 7 x pieces. And 7 x pieces this way. 3, 4, 5, 6, 7. And there's going to be 49 ones. Lots of them. 49 ones. Which works out. And it is, as you can see, a perfect square.